So welcome to the learning series. We're looking at the new exam questions that came out as of July 15th, 2025. And now we're continuing on with the second section of the basic section on electricity. So the exam questions are on the left-hand side. Anything new is explained on the right-hand side. And then new questions are in bold. One thing that's been added is the block diagrams. So they come in two versions, one that you can study from and one that you can use during the exam, and these will be supplied to you as part of the exam. So here's what the study aid would look like, giving you the formula plus the explanation or a diagram with all the components labeled. But the reference material that will be provided with you with the exam will have the formulas, but will not have the explanations of it. And same goes for the block diagrams. So in this section here, because we're doing Ohm's law and power, these equations can be helpful for you. And we're also going to be looking at resistance and capacitance and inductance in series and parallel. So this can also be useful for you. So we're on section 5. And now we're going to cover decibels, inductance, capacitance, reactance, impedance, transformers, which has been a new section that's been updated quite a bit, resonance, and then meter and measurements. So when you're comparing two different items, you get a ratio, and often the ratio is expressed in terms of decibels. And a 2 times increase in power results a change in how many dB. So a 2 times change is a 3 dB higher. So A is the correct answer. So if it's positive, it's an increase. If it's negative, it can be expressed as a decrease or as a -3. So what change in transmitter power results in a 3 dB decrease? So here 3 dB would be half. So you would decrease the power by 2. So A is the correct answer. What change in transmitted power results in a 6 dB change? So 3 dB is 2, so 6 dB would be 4. So D would be the correct answer. Is multiply the original power by 4. Here is another question. This has to do with S units. So if a signal transmitted with a power of 200 watts is received with an S meter reading of 10 dB over S9, what would be the new reading if the power was reduced to 10 watts? So here you would go from 200 watts to 20 watts, which would be 10 times. That would be equivalent to 10 dB. So you'd simply cross out the 10 dB because you're over S9, so the correct answer would be S9, which would be B. If a signal transmitted with a power of 150 watts is received with an S meter of 20 dB over S9, what would the new reading be if the power was reduced to 15 watts? So 150 to 15 watts would be 10 times, which would be 10 dB. Since you're 20 dB over S9, you subtract 10 dB from 20, gives you 10 dB over S9. So the correct answer would be C, S9 plus 10 dB. What is the decibel used for? So as I mentioned before, it's a measure of the ratio of two signals. So B is the correct answer. The output of a transmitter increases from 1 watt to 2 watts. how many decibels does this represent? So it's from 1 watt to 2 watts is 2 times. So 2 times is 3 dB. So B is the correct answer. A power of a transmitter is increased from 5 watts to 50 watts by a linear amplifier. What is the power gain expressed in dB? So 5 watts to 50 watts is 10 times. So 10 times is 10 dB. So the correct answer is B, 10 dB. You add 9 dB gain amplifier to a 2 watt handheld. What is the output of the combination? So so if you when you go from 3 dB, 3 dB is 2 times, 6 dB is 4 times, 9 dB would be 8 times. So 8 times 2 would be 16 watts. So D is the correct answer. Here's a new question. The power of your transmitter is 100 watts, and the transmission line introduces a loss of 6 dB. How much power is delivered to the antenna? So remember again, 6 dB is 4. So you would take 100 divided by 4, which would be 25. So C would be the correct answer. A local radio operator reports receiving your 100-watt 2-meter simplex transmission with an estimated reading 30 dB over S9. What power could you use to reduce this reading to S9? So because you're 30 dB over S9, you want to get down to S9. So that means you have to decrease the signal by 30 dB. So 30 dB is 1,000 times. So you would take 100 divided by 1,000. So it would be 0.1 watt. So B would be the correct answer. So now we get into inductors and capacitors. So the thing to remember here is that an inductor behaves similarly to a resistor when they put into series and parallel. So if two equal value inductors are connected in series, what would be the total inductance? So you just add the two together. So it would be twice the value of one inductor. So the correct answer would be D. If two equal value inductors are connected in parallel, so again, similar to a resistor, you would divide that by 2. So it would be 1/2 of the value of one inductor. So C would be the correct answer. If two equal, okay, the thing to remember now, we're talking about capacitors. Now, capacitors behave the opposite of resistors and inductors. So when you connect two equal value capacitors together in series, so what you would do is you would treat it like resistors or inductors in parallel. And so in series would be half for a capacitor, so half the value of either capacitor. So B would be the correct answer. If two equal value capacitors are connected in parallel, remember it's opposite of inductors and resistors. So here you would add the two values together. So it would be twice the value of one capacitor. So B would be the correct answer. You are constructing an air core inductor using coil wire. What parameters did you determine its inductance? So what's important here is A, coil diameter, the length of the coil, and the number of turns of wire. So A would be the correct answer. A capacitor is made of two identical metal plates separated by air. So what parameters determine its capacitance? So that would be the surface area of the plates and the spacing between the plates. Here's a new question. What precaution must you take when using polarized electrolytic capacitors? So because it's polarized, they're marked with a plus or minus. So you don't want to apply a reverse voltage to them because they can explode. And so C is the correct answer. Never apply a reverse voltage to polarized electrolytic capacitor. Here's another question. If you wire two 12 millihenry chokes in series, what is the inductance combination? So remember, this is similar to resistors. So 2 times 12 or 12 plus 12, correct answer is 24 millihenries. If you wire two 20 millihenry inductors in parallel, remember this is similar to resistors. So it's 20 divided by 2, which would be 10. So D would be the correct answer. Now we talk about capacitors. So remember, it's the opposite. So if you wire two 20 microfarad capacitors in series, what would you do? So in series, you would divide 20 by 2, giving you 10. So B would be the correct answer. If you wire two 24 microfarads capacitors in parallel, what would be the capacity of the combination? So here it would be 24 plus 24, or 24 times 2. So the answer would be 48 microfarads. So B would be the correct answer. Now we get into reactance and impedance. So capacitors and inductors behave differently when they're exposed to AC. So for an inductor, what happens here, as the frequency increases of the applied AC, let me state that again. As the frequency of the applied AC increases, the reactance increases. So the inductive reactance increases. So D would be the correct answer. How does a capacitor react to AC? So remember that a capacitor is opposite of an inductor, so it would behave the opposite. So as the frequency of the applied AC increases, the reactance or capacitive reactance decreases. The reactance of capacitors increases, so remember the opposite. So it's as the frequency decreases. So D would be the correct answer. What is the term for the opposition of alternating current caused by the combination effect of reactance and resistance? So what happens here is if you add reactance and resistance together, you get a term called impedance. So B is the correct answer. There's a new question. So what term equals the ratio of AC voltage to AC current in a system or circuit? So this is Ohm's law for AC. So instead of resistance, you have the term impedance. So A is the correct answer. What circuit parameter change causes an inductance inductor's reactance to increase? So remember, this is when you have a frequency. When the frequency increases, the inductance reactance increases. So C is the correct answer. What property allows a coil wound on a ferrite core to mitigate the effects of an offending radio signal? So here you have to think of what happens to reactance with a radio signal. So it's high reactance at radio frequencies. So A is the correct answer. What property allows a bypass capacitor in an audio circuit to divert an interfering RF signal? So again, remember, it's low reactance at radio frequencies. So A is the correct answer. What property allows an RF bypass capacitor to have little effect on an audio circuit? So here you have high reactance at audio frequencies. What property allows an RF choke to have little effect on signals meant to flow through the coil? So here again, remember, low reactance at low frequency. So A is the correct answer. In general, the reactance of inductors increases with. So again, it's related to frequency. So as the frequency increases, the reactance increases. So D is the correct answer. Okay, so now we're getting into a whole new section of transformers. And so what you have to remember here is the primary equals the secondary in terms of power when you're doing these calculations. Although there may be a little bit of loss when you're doing the calculations, you don't assume a loss. Also, you can also look at this in terms of a turns ratio. So here they give you, you have 120 volt primary that supplies 250 watts to a transmitter. What is the approximate primary current? So you would use the formula here, I equals P divided by P divided by V or pi. So you would take 250 divided by 120. So that would be 2.1 amps. So A is the correct answer. How can a transformer with two windings change the impedance? So that can happen because both windings could be at different voltages and different currents, and that results in an impedance being changed. So B is the correct answer by having different voltages and currents in each winding. So a transformer with a single 12-volt secondary draws 0.5 amps through its 120-volt primary, assuming no losses. What current is drawn through the secondary? So you're going to have to do a calculation here, and the voltage ratio is 10. So 10 times 0.5 is 5 amps. So B is the correct answer. You can also do this in terms of the turns ratio. So the primary winding of a transformer has 250 turns. The secondary winding have 500 turns. If you put in 120 volts, what's your secondary voltage? So you have twice as many turns. So the secondary would be twice 120. So the correct answer would be 240 volts B. The strength of a magnetic field around the conductor is directly proportional to the current that's flowing through the conductor. So B is the correct answer. The maximum induced voltage in a coil occurs when current is going through at its greatest rate of change. So A is the correct answer. Here's a new question. The transformer primary winding consumes 10 watts, neglecting losses. If the secondary voltage is 10 volts, what would the secondary current be? So here you would do the calculation, and that would be A, 2 amps. So 10 divided by 5 is 2, so 2 amps. Step-up transformer with a primary to secondary turns ratio of 1 to 5 delivers 50 milliamps to a load. Assuming 100% efficiency, what is the primary current? So what you're going to have to do here is increase it by 5. So that would be 250 milliamps. So C is the correct answer. Here's a new question. What is the coupling inductance between two wires maximum? And that would be when the two wires are close and parallel to each other. So A is the correct answer. A permanent magnet would most likely be made of. So B, steel would be the answer. What confirms the fact that the transfer of energy between the primary to secondary of a transformer is not perfect? So what happens here is that it heats up the iron laminations. So the transformer is warm. So A is the correct answer. Now we're getting into resonance. So resonance is the condition that exists when the inductive reactance is equal to the capacitive reactance. You get resonance. So A is the correct answer. At resonance, what impedance does a parallel tuned circuit exhibit? So they're talking about impedance here. So it's either high or low. So the correct answer is C, high impedance. A new question here. What is the resonance frequency of a tuned circuit? What resonance frequency of a tuned circuit is a single frequency? The effect of resonance is significant over a certain range of frequencies. What is this called? So, so as you vary the frequency, um, the circuit will have a bandwidth. So A is the correct answer. Which two components are required to form a tuned circuit? So that would be because you need an inductor and a capacitor. A would be the correct answer. When the parallel coil capacitor combination is supplied with AC of different frequencies, there will be one frequency where the impedance is the highest. So what would that be? So that would be the resonant frequency. In a parallel circuit at resonance, the circuit has D, that would be the high impedance. In a series resonance circuit at resonance, the circuit has B, low impedance. B is the correct answer. A coil and air-spaced capacitor are arranged to form a resonant circuit. The resonant frequency will remain the same if we have if we add a resistor to the circuit, the resonant frequency doesn't change. Resonant circuits in the receivers are used to deselect the desired signal frequencies. So D is the correct answer. Resonance is a condition that exists when the inductive reactance and the capacitive reactance are equal and opposite in sign. What happens to current in a series RLC circuit is tuned to the frequency of the source. So that means it reaches its maximum. So C is the correct answer. Okay, now we get into the section here on measurements. So how is a voltmeter usually connected to a circuit on the test? So that's in parallel with the circuit, so that's A. How is an ammeter usually connected to a circuit on the test? That would be in series with the circuit, so B would be the correct answer. What does a multimeter measure? So a multimeter generally measures voltage, current, and resistance. So B would be the best answer. Some of the newer meters could measure resistance, capacitive, and inductance, but would also measure voltage and current. So B is the best answer. What is the correct instrument to measure the final power amplifier current? So in this case, you are measuring current, so you would use an ammeter. So D would be the correct answer. Here's a new question. When measuring the voltage across a circuit component, what does the voltmeter appear to be in a circuit? So you want the voltmeter to be a high resistance value, so it doesn't load the circuit. So A is the correct answer. When measuring current drawn from a DC power supply, what does the ammeter placed in the circuit appear as? So in this case, you want the ammeter to be as a lower possible resistance as possible. So so it doesn't load the circuit. So B would be the correct answer, a low value of resistance. Here's a new question. What instrument can provide a direct measurement of power at the output of a transmitter? So since you're measuring the output, you're looking for a watt meter. So B would be the correct answer, an RF watt meter. Potential difference is measured by means of. So remember, potential difference is the same as voltage, so you would need a voltmeter. So A is correct. What instrument is used to measure electric current? So in this case, you want an ammeter. So that would be D, ammeter. A new question. What term describes the ability of an instrument to display values that are true to reality? So in this case, it would be the accuracy of the instrument. So C is the correct answer, accuracy. So next week, we're going to look at feed lines and antennas. It'll be divided into two sections, the left side being feed lines and the right side being antennas. So let me just stop the recording for this.